Hello everyone. In this video, we are going to study document object model for XML processing. Before we get into how the DOM works with XML, let's first understand what XML actually is. XML stands for Extensible Markup Language. It's a standard way to encode documents so that both human and machine can understand and process them. Like HTML, XML uses tags, but these tags are custom and define your own data structures. One of the biggest strengths of XML is that it's readable by both human and machines. Here is a simple example of an XML. Now that we understand what XML is, let's look at how we actually interact with it. That's where the document object model or DOM comes in. The DOM represents XML as a tree structure in memory. Each tag in the XML becomes a node, and nodes can represent elements, attributes, and text. This makes it easy to navigate and manipulate XML data using code. What's powerful about the DOM is that it provides language neutral and programmable interface. That means we can use languages like JavaScript or Java to access and modify any part of the XML document directly. There are several DOM implementations. For example, in Java you might use Jaxp and or Xerces, which offers tools for parsing and manipulating XML. These tools follows some basic structure which makes your skills transferable across platform. On the left, you can see a visual representation of how elements, attributes, and text nodes are structured hierarchically. This is what the DOM looks like behind the scenes. Let's now look at how the DOM actually works when processing an XML file. This process is called DOM parsing and it happens in 5 main steps. First, an XML parser reads the entire document. This is done from top to bottom, capturing all the tags, attributes, and text. Next, parser constructs a DOM tree in memory. Every element becomes a node in this tree, forming a structured and searchable model. Once the tree is built, applications can access the modify any part of it, whether it's reading data, changing values, or adding new elements. After modifications are done in memory, the updated data can be written by to the file or stored in another format. One thing to note is that DOM parsing can be resource intensive, especially for large XML files, because the entire document must be loaded into memory at once. Now let's look at the key advantages of DOM parsing which make it popular among developers working with XML. First, DOM gives you full access to the XML document. This means you can read, update, or delete any part of the document's structure. Second, it has a simple and consistent API for navigating and manipulating data. Even beginners can quickly learn how to use it effectively. DOM also supports XPath, which allows us to perform complex searches and queries within the XML. This makes data retrieval fast and precise. Lastly, DOM is ideal for small to medium sized XML files. It loads the whole document into memory, making it efficient for quick operations. While DOM parsing have several benefits, it also comes with some important drawbacks you should be aware of. First, DOM requires entire XML document to be loaded into memory. This can result in high memory consumptions. For large XML files, processing becomes slower because of this heavy memory uses. DOM is also not ideal for streaming data since it needs the full document loaded upfront. It doesn't handle real-time processing well. And finally, with very large dataset, there is a risk of memory errors like out of memory error. Let's now look at a practical example of DOM parsing using Java. First, we load the XML file into DOM tree. Then we can access or modify any element or attribute as needed. After making changes, we serialize the updated DOM tree back into an XML file. In the code snippet, we start by creating a document builder factory instance. Then we use it to create a document builder. With the builder, we parse an XML file, in this case file.xml. Once loaded, we can modify the DOM structure and save the changes back. To wrap up, let's look at some best practice and key takeaways for using DOM parsing effectively. First, always optimize memory usage. DOM loads the entire XML file into memory, so careful management is crucial. Second, validate your XML against its schemas such as XSD. This ensures your data is structured and reliable. For very large documents, consider using alternatives like SAX or STAX. These are more memory efficient for streaming data. In summary, DOM provides full access to an XML document structure, but this comes at the cost of high memory usage. Thank you.